My name is Greg Abry. I'm with Abry Brothers. We're a sixth-generation family business. We raise houses, elevate houses, and do foundation work. We've been working in New Orleans for the last 168 years. The company started in 1840 by my great-great-great-grandfather. The original founder, John Abry, was a native of Frankfurt, Germany. He was an established, skilled house-moving contractor in Germany. When he found his way here, just by fate, wound up in a city that has sinking problems and foundation problems. And we've been successful and stayed in business since then. This is the Tulane Alumni House. This was built in the early 1940s. It was a private house until the owners died and willed it to the university. Tulane then created the Alumni House, and this is where all their alumni efforts and campaigns come from. And so it's really a hallmark building on the campus. It's very recognizable to people who have gone to Tulane.
Apparently there's a desire from the alumni to want to save this residence, and it was flooded during the Katrina, I guess, flooding, and it has to be raised to a new elevation to satisfy the FEMA requirements of today.
In the case of Alumni House, looking at it, if we can raise it up above the floodplain, and we have a future incident of the same magnitude, we should come through it with no damage or minimum damage at most, certainly significantly less than occurred this time. So our mitigation strategy is to elevate the house, and that's of course what brought Abry Brothers in as our contractor to do the actual elevation.
Right now what's happening is, if you can see behind me, we've engaged Abry Brothers to raise the house, and it'll be raised to a level, this is an important point, that's higher than the flood event, so that we'll be sure that in the future this alumni house, which is representative of the whole university, I mean it's the beacon for the rest of the university, will be protected.
This is a FEMA mitigation project where FEMA will come in and participate in some of the costs it takes to get houses and buildings elevated above base flood to prevent future flooding. So we were contracted to come in and elevate the house, and we're going to elevate it about 32 inches to get it above that high water mark that FEMA has set for us.
We're very fortunate to have them on the job. They're very meticulous about their work, and what's incredible here is that they've taken the initiative to bring the type of equipment here that will raise this house all simultaneously. So we're very happy to have them on the job, and particularly as the architect that's responsible for this, I can speak, volumes about working with them and how professional they are.
The key to it is with Jeremy to come in, and he's going to start.
We're going to get that deflection.
Right, start deflecting the beams and making sure all the load comes up. Because you got to kind of get it balanced. You got to see what pressures on what jacks they got it the heaviest, and then once they get that tuned in with the unified system, that big system Jeremy has, it locks in. Regardless of pressures, regardless of anything, it's going to stroke up the same amount. Yeah, it's going to go up. We got 40 jacks set on 20 different cribs to bring it all up evenly. We're probably going to get some stroke on our jacks that's not going to cause the building to come up. You're going to lose some stroke just because of the soft soil. But we'll work all that into the raising.
Do you have a guess how much this weighs?
320, 350 ton.
To successfully raise the house, what we've done is we've installed a series of steel beams to create a steel framework, a very rigid steel framework under the house. This will support the house, and is with my jacking system will raise in order to get the house to elevate evenly without it twisting and torquing to get a nice even lift. So under the house what we have is a series of hydraulic jacks. There's about 48 jacks set under the house on wood cribbing, which is then going to raise the rigid steel framework which is supporting the house.
You know, it's a 24 jack unified jack machine. It's the second largest unified jack machine sitting in the United States. It gives us 20 points to control on our cribs. You know, we actually have 4 extra points on our machine for this job. You know, it's the machine for the job. It allows us to control individual points and pressure up without cracking. The biggest challenge here is the soil conditions down in Louisiana, because if you dig down 18 inches, you're in the water table. So one of the biggest challenges is putting that 350 ton up in the air without any settlements. That occurs to be the biggest challenge down here.
The type of construction, the way the house is built, it was built on a solid concrete wall with the wood framing sitting directly on top of that. So in order to install our steel beams, we had to saw cut holes through each spot in the foundation in order to receive the beams to build under the house.
We put 20 cribs under. You know, we're going to use 2 times the jacking force that is required to elevate it, just so we don't have any settlement or problems.
Today we have our steel framework and our cribbing and jacking system prepared. We're going to start applying pressure to the hydraulic jacks through a unified hydraulic jacking machine specifically designed for elevating houses and raising houses. Once the pressure is applied and we start the lift, check to make sure everything is free and is coming up properly, then we can lock this system down into a unified system and then do a full raise. Looking good. Got an even crack all the way around, and we'll put a little more pressure on it. Get about 1 inch, and then we'll go check everything inside. The jacks will raise 10 inches at a time on the first raise. Then we'll convert over to our longer jacks, which can come out 14 inches. If the cut over the beam wasn't clear, as the beam slides past it, it'll rub.
Yeah.
She's free now.
Good.
You happy? Happy. That's the way they're supposed to come out. Yep. Looks like work.
Yeah. I'm glad my side's about done now.
Yep.
We're lucky. We all got good guys. I mean, that makes a hell of a difference. Let's get some champagne crackers.
Pop open. Once the house is at its final elevation, we'll start rebuilding the foundation walls by adding concrete blocks on top of the existing walls, filling the cells with concrete and steel all the way around the perimeter and the inside of the house. Once that's done, then the steel can be released and the house is sitting back on the foundation at its new height. The architect that is in charge of the project, the engineer who designed the structural part of it, was here, and Mike Jester, who's in charge of facilities here, came by, and they all stayed till we left on Friday evening, you know, watching it raise and checking everything out. So it really went well. If you look at, you know, the condition of the building, the way it lifted, the whole process went very smoothly. So it's always everybody breathes a big sigh of relief, because there's so many unknowns when you know, you take on a project like this, people think, you know, geez, can this really be done? So it took a little, you know, a little faith to start with, and then they started getting a little comfort zone once they start raising and everything coming together.
Oh, my go. Let me see. It's all about the
Man! I went across the street. Good job, guys.